Hi, I'm Michelle, and today I'll be talking about our paper on end-user audits. In September 2020, Twitter users identified and investigated racial bias in the algorithm used to automatically crop images in tweets. Given carefully constructed examples with images of Barack Obama and Mitch McConnell, for example, they found that irrespective of the placement, the algorithm would always select to crop out Obama and show Mitch McConnell. These tests grew viral as more and more users tested out their own variants, and ultimately, it caught the attention of Twitter engineers. Twitter then addressed this issue with the algorithm, marking a major success for organic, user-led investigations of algorithms. So amidst all of this discussion about what systems we should audit, what things we should check for in audits, and how we should address audit findings, this Twitter example raises the question, who is conducting these audits? Currently, it's typically a group of technical experts, such as researchers, data journalists, and engineers. But in all sorts of social communities and deployments of algorithmic systems, different kinds of errors can arise that members of those communities would be best able to uncover. Taking the example of a content moderation algorithm, the goals of moderation would look very different for these different communities, and an external technical expert outside of these communities may not even be able to detect what those community members would perceive as errors. So we'd like for communities to have some way to lead their own audits, but it is currently very challenging for everyday users to conduct algorithm audits. If users identify a few examples of harm, these are often disregarded by system developers, as limited examples may have been cherry-picked, and it can be hard to use these to diagnose and mitigate issues. But if users are meant to conduct a systematic audit, this often requires technical expertise to gather and test large amounts of inputs and analyze outputs, and this takes a significant amount of time and effort to carry out. Emergent cases like the Twitter example can only happen when inputs to the algorithm are easy to formulate, where evidence of bias is extremely stark, and where user tests can gain viral attention, enough to prompt someone like Twitter to take action. In our work, we address this effort barrier by introducing end-user audits, system-scale audits led by individual, non-technical users, members of these communities who do have this rich situated knowledge of the particular impacts that algorithmic systems have on their communities. Our approach tackles this problem using information already present in most machine learning datasets, labels from annotators in the training data. Many of these existing datasets used to train algorithmic systems already contain a variety of perspectives and represent annotators with a range of identities. With our approach, users initially provide labels on a small number of samples. Then, using methods drawn from recommender systems, we can project their labels onto the space of diverse annotators, and can use similar annotators' data to predict the user's labels for the full, much larger dataset. In particular, we explored two technical approaches to perform this projection. First, the simpler SVD algorithm, which allows for interactive model training and iteration, but achieves lower accuracy in predicting a particular user's labels. Then we explored a deep learning version based on the jury learning architecture, which was too slow for interactive use cases, but could achieve much higher accuracy. With these approaches, if the user provides their ratings on the toxicity of 20 text comments, we can predict their toxicity rating on hundreds of thousands of comments. This provides a launchpad from which the user can investigate issues. Because now, with this full set of many thousands of predicted user labels, we can compare against the system's predictions on those same examples. This then allows us to calculate user-centered performance metrics and discover areas where the user's labels disagree most strongly with the target system's predictions. These indicate areas where the system that they're auditing may be failing, and where the user's assistance with conducting an audit may be most needed. From there, we can surface exactly those areas of disagreement in our end-user auditing interface. Users can dive into data visualizations and get a sense of the kinds of errors happening in this topic area, diving into examples of comments and gathering evidence of types of errors. Then, after conducting a series of audits, they can finalize these into an audit report that can be shared with system developers. We instantiated our end-user auditing approach in a web-based tool called IndieLabel that supports algorithm auditing for comment toxicity models. First, users start with the labeling page. Here they provide their small set of 20 labels to train their personalized model and optionally provide additional labels to tune their model on a validation set. Then they can proceed to the main auditing page. Here, there's an audit report side panel where they can keep track of their audit topic and evidence and switch between different candidate audit reports that we've automatically suggested. Then there's a main auditing panel that contains visualizations that highlight likely system errors based on the predicted user labels, highlighted in red. Users can investigate these visualizations and dive into examples, mark notes, and save evidence. They can also conduct additional keyword searches and custom clustering to further investigate hypotheses. We conducted an evaluation with 17 non-technical users and had each participant take part in a 1-hour session where they used our IndieLabel tool with 10 minutes for labeling and 30 minutes for auditing. The participants used the system to audit the Perspective API, a well-known API developed by Google that uses a machine learning approach to detect toxic comments. Users were successfully able to use our end-user auditing approach to surface on average 4 to 5 potential issues, in total spanning 57 distinct topic areas. The vast majority of participants discovered system issues that they hadn't anticipated beforehand. And the scaffolding we provided was important, as only 2 of 17 felt that they might have discovered the same issues without a tool like IndieLabel. Also, users independently raised the same kinds of issues with Perspective API that had been documented in past expert-led audits. But they also found issues that had been previously underreported, such as overflagging on sensitive topics like race, slavery, and sexual assault. Then, there were 3 kinds of trends among the issues raised by end-user auditors. First, there were converging issues, where there was substantial overlap among issues and fixes raised by participants. For example, participants largely agreed that uses of reclaimed slurs within marginalized communities should not be flagged. Then there were diverging issues, cases where within the same topic, users had insightful, differing perspectives. For example, some users thought that speech against white people should be flagged, but others thought that there needed to be space for this discourse. Then there were unique user insights, cases where users were able to identify unique system issues that other users did not identify and that had not received much attention in previous audits. For example, users investigated issues related to the presence of marginalized identity terms related to their own identity, and one user raised the issue that the system missed nuance and awareness of consent in body-related discussion. We see several encouraging opportunities unlocked by end-user auditing. Converging issues surface clear wins where users are largely aligned. This makes the case for mitigation and prioritization clear. Diverging issues, on the other hand, might help developers to understand the nature of disagreement and map out trade-offs, because sometimes differing justifications for the same issue can imply different solutions. Unique issues surface cases more akin to unknown unknowns of a system. The size of a group is not always commensurate with the severity of harms it experiences, so it's important to be able to learn of issues that may impact smaller numbers of users. End-user audits can also provide an opportunity for system developers to shift the timing of feedback and catch issues preemptively before launch. Developers can run an end-user audit as soon as they have a dataset and a version of their system to test, so this can allow for fast accountability loops. End-user audits can also enable users to not only identify problems, but to leverage their rich contextual expertise to provide some of the reasons for the system errors and potential solutions to address these problems. We see our approach as a complement to the status quo of group-based algorithm audits led in a top-down manner by technical experts. We're excited to see end-user audits work toward a mode of algorithmic accountability where individual end users can have greater agency to leverage their expertise and raise algorithmic harms. Thank you for listening to our talk.